So we're going to be working on these chapter 2 exercises here, and you can see I have the exercise descriptions up on the screen. But the first major concept that we're going to start tackling is this thought of what is a variable, right? And so when you hear that word, just as a word, right, it means something that can change, right? So that something is variable, it implies it is changeable. But there's also a separate implication to this. That means it can hold value. And I always tend to think of, and this is kind of a thing that's kind of stuck with me over the years, because I hear different people using different analogies. So I'm going to just draw on the screen here, kind of in a blank spot if I can find one. I always think of a variable as a box. That's my construct, In a box, think of what a box is, right? A box is a cube or whatever. It's like this container, basically, and I can put stuff inside that box. And I can take stuff out and put other stuff in. That box might be empty, or it might be full, or it might be part full, The other thing is, if I have multiple boxes, it's probably smart. So let's say I have a couple of boxes. Probably smart to name those boxes. So I might have one box maybe called length. I'm kind of playing off the fertilizer example now. Maybe another box called width. And kind of the point of this is, well, what would you put inside those boxes? Well, that one's marked width. Maybe I should put the value for width inside that box. Now, the one difficult thing for people when they're first starting to program is the fact that when we write computer programming code, we often write the code with variables like in our equations and our statements. So to represent the concept of whatever it is that we're working with, but allowing the value to be changeable in order to accommodate whatever we're doing. So in the fertilizer example, some of you, when you did the flow chart, were doing this. They would put in the equation, which is the correct thing to do, without values in it. And then they would put in the equation with all the values in it and the math result. That part is not needed in a program. The program, that's why you're writing the program, is to figure that out. That's kind of the point. So we use these variables kind of as important placeholders. And then what can you put inside of them? Now, Python is what we call a not strongly typed language. And I want you to hear the word not, right? In other programming languages, so some of you right now might also be taking Java. Is anybody in here taking the Java class? Okay, a few of you. So you guys are probably well ahead of this material already, especially if you have Christian. Christian tends to move pretty quickly. And you have probably learned that in Java, when you have a variable, you have to declare what type it is. So you can't just put whatever you want into the box. If it's a counting number, an integer, you have to declare the variable as an integer, and then you can only put whole counting numbers into that box. You try to put a word in there or a floating point number, it breaks. And then you create other types of variables, let's say like a double that holds a floating point number. Can't hold words, can't hold counting numbers. Then you can also create another class of variables in Java called strings, which are words instead of quotes, characters on the screen. And in order for any of those constructs to work, you have to say formally what it is and then put the stuff in. A couple of languages that you're going to learn in your program, Python is one and JavaScript is another, are what we call not strongly typed languages. They're also not compiled languages, but allow you to create a variable, and I can throw a number in there, counting number. I can throw a floating point number in there on my next statement, and then I can throw words in there, and it doesn't care. And it just works, right? That is more anomalous in programming than normal, by the way. So when you are working with variables, usually it's a really good intention, at least, to think about what's going in there, name it appropriately, and then usually only put one type of value in. And some people actually use the flexibility of JavaScript and Python to do crazy things that you can't do in other languages. So, and there's reasons for doing them. and they're mostly programming shortcuts. But for the most part, you want to think about what's going into a box and kind of pre-plan it, and more importantly, name it according to what's going in. So if I'm storing the width of a lawn in one variable, I don't want to call it fertilizer, right? Because that makes no sense, because that's not what I'm putting in there. So name it accordingly. And the other kind of general rule, at least in modern programming, is to be really verbose with how you name your objects. So if I'm contending with the width of a lawn and the width of a lawnmower, I probably want to name them like that. I would say width of lawnmower, width of lawn. I wouldn't call each of those variables a width. So that's kind of my first little lecture point there. Let's go ahead and get Spyder up on our screen here and get coding. And so I'm launching the Spyder IDE. I'm also kind of getting my cheat sheet notes going here on the other screen. You guys bear with me as I do that. And yes, you can see it all jump up there. And that's one of the advantages of dual screening. So those of you that are like zooming into this today in particular, I know the people here in the classroom, I mean, if you have a laptop, you can always use the computer, the school machine for your second screen, I suppose. But I really strongly suggest that you get into this habit of kind of dual screening if you have that capability when you're writing code, because it's really good to have instructions on one screen, code on the other, Zoom session on the other screen too, and you can kind of keep it all going at the same time. All right, so I'm pulling up like I said, my cheat sheets here. All right, so the first exercise that we have to complete here is going to be exercise 2.1, and I do have that on the screen already. It says, write a program that displays the dimension of a letter-sized sheet of paper in millimeters. There are 25.4 millimeters per inch. So this is a pretty critical piece of information for this. So we're given a piece of information that's helpful. Now, if we weren't given that, could you figure that out? Yep. Hello, Google, right? How many millimeters in an inch? And just in case you didn't know, it's 25.4. Makes no sense, correlation number-wise, but that's what it is. And here it says use constants and comments in your program. So now they're asking us for a couple of other things. So we already talked about what a variable is, but now you have this other concept of a constant, and the constant is like a variable that you're not supposed to change. And I'm using those words really cautiously here. When you are learning Java, and some of you are doing that, when you have a constant, you actually put a declaration in front of it that makes it so you cannot change the value of that variable. So really good example. I mean, the conversion of what millimeters per inch is makes sense to make that a constant value. You don't want like one day for it to be 25.4 and the next day it's 25.5, right? It should never change. The problem with Python is Python does not have a structure for constants. So it's possible to change a value of something you're considering a constant. You just have to remember not to. And the trick that we use in Python is naming it with all capital letters. That's the trick. All right. But it's more of a conceptual construct than an actual construct is really kind of a good way to say it. All right, so here comes the Spyder IDE, folks. And I am going to zoom in, and you can see I have my work from last time still on screen here, and I'm just going to begin by closing all of those old programs. That's me. You can keep them open if you want, not a big deal. When I close all the open tabs, Spyder automatically creates a blank file for me to do my coding. And so here I am with a blank file. What's the first thing I should do? Okay, very good. Somebody's learning. Thank you. Right, that's a very, I clicked new instead of save, apologize. So let's save that, and this is going to be exercise 2_1. I'm going to name it just like that, 2_1, but I need to put it in the right place. For me, that's in my Google Drive, and for you, it might be a different location. And so I have my file system, you have yours, but please make sure that you put it somewhere that makes sense. I see that I don't have a Unit 2 folder in here yet, so I'm creating a Unit 2 folder. And actually, I'm going to be even smarter than that, because if there's 2 sets of exercises, I'm going to rename it Unit 2 Part 1. Makes sense, right? 2 exercise sets. So that's Unit 2 Part 1. Oops, I deleted the other part, so I'm renaming it again. Isn't it fun to watch the teacher fumble? Absolutely. As long as it's not the Packers, we're fine. So that's what you call low-hanging fruit, folks. Oh, the Packers did okay this past weekend. Once again, I'm a fan. The first week of the season, not so much. All right. So I'm putting my work in Unit 2, Part 1. I have it named X2_1, and I'm hitting save. All right. The other thing that I sometimes do, and this is just a helpful tip, is sometimes when I get the directions for creating a piece of software or creating a program, especially as an assignment, sometimes it's such a pain to have to switch your screens back and forth. What did it say? So I got in the habit a while ago that when the instructions are fairly simple, I just come in here and copy it, and I just paste it into the program. And where do I put it? I put it right up here at the top in what we call a comment section of the program. And so we talked about this briefly, I think, last week. But you notice that there's a set of like 3 double quotes and then another set of 3 double quotes. And really what that's doing is it's setting aside that section of the document as non-functioning code. It's just words on the screen. So I'm going to paste the instructions for the exercise right there. So we got a superfluous 1 there. I'm also going to turn on my word wrap. And if you guys notice that right now, this is going off the edge of the screen, right? That's not very helpful for me. And I want to turn on word wrap. Does anybody know how to turn on word wrap for this? Anybody figured that out? Somebody said file, not seeing it there. Edit, search, source, right? You just start going through all the different menus looking for it. And if I remember right, in this tool, we have to actually go to preferences, and then the editor. You guys see how I did that? And then there is an option right here that I'm hovering over right now that says wrap lines. So just to repeat how I got there. Tools, preferences, editor on the left sidebar, and then right here it says wrap lines. And so as I click on that and say okay, now you'll notice that that long line that I pasted in is now wrapping down, and it will dynamically adjust to the window. That's generally a setting I recommend in most editors. Right. But now my instructions are right there and I can see them. In your book, they gave you a different way to add comments. Can somebody tell me what that way was? Yes, Nick.
I might be mistaken. It was like 2 hashtags and then 1 hashtag and 1 hashtag.
Okay, so yeah, you're thinking of kind of like an approach like this, right? And this is a hashtag or a pound symbol. And here, I'll even zoom in a little bit so you can see it. Yeah, that is more traditionally the comment mark. And really all you need is 1. So once you put in a pound sign on your code window, anything that you type after it will not become part of the program. But it's information that you might have useful as a programmer, either notes for yourself or notes for others that might look at your program later. And so real common thing to do is to comment your code to describe what it's doing. And so, for example, the first thing I'm going to do is I'm going to declare the constants for the program. Okay, and I'm being probably a little bit more verbose than I need to be, but now it's pretty clear what's going on. I'm marking it. You notice how it's kind of grayed out too? So that's another tip. So that's how you do a comment. And they're asking you to include one. So here's one that you can include. All right. So the first thing that we have as a constant is they told us that there's 25.4 millimeters per inch. All right. So we're beginning by writing a constant. And the convention, remember, is to name it in all caps. And then if you have logical words within the name, separate those with an underscore. And notice how verbose the statement is. I didn't go like ml per I or in or something like that, right? You know, so for example, I could have done something like ml per, right? And that's could represent the same thing, but it's harder to read. And you might still be, what's a milperin? You know, somebody might go, right? Whereas if I use a name millimeters per inch, that's very descriptive and to the point, and it is kind of a modern programming convention, I'd say within the last 10 years or so, that people are saying, you know what, all this like abbreviated naming of the past is silly, let's name it really verbose, exactly what it is, so there's absolutely no guessing, okay? To the right of this, I'm going to put an equal sign, and then I'm going to put the value 25.4. Now, a couple important things are happening here, right? Remember, the all caps implies that it's a constant. The reality is Python has no constants. So that value can actually change. But the thinking is once we see it in all caps, we'll go, oh, no, we can't mess with that one. It's a constant, right? So generally speaking, don't mess with it. The other thing that happens is we have an equal sign. And this is probably the first confusing thing that you'll probably encounter in programming is you learn an equal sign in mathematics means that you're creating an equation, and after the equal sign, you put the answer, right? So 1 + 1 equals whatever, right? In programming, it's a different implication. The equal sign, a single equal sign, and this is important because if it's double or triple, it's something else. But a single equal sign is what we call an assignment statement. So it means that whatever is on the right of the equal sign is being assigned to the item on the left of the equal sign, meaning 25.4 is going into a box named millimeters per inch. Okay, so it's not really a box. What really is it? It's a spot in the computer memory. It's a spot in RAM on your computer that is being set aside to hold that value. Isn't that fascinating? So you are actually creating something. By creating a variable, you're taking up a portion of the computer memory to store a value. When the power goes off on the computer, by the way, that is destroyed. When the computer's not running, that value goes away. We're not writing it to the hard drive here. We're writing it to RAM. And that's a really important concept too. But here we have our constant now for millimeters per inch. Now, you might not think of it this way, but the program says, write a program that displays the dimensions of a letter size 8.5 by 11 inch sheet of paper in millimeters, or 25.4 millimeters per inch. There are other constants here. Now, some people see this and some people won't. But a standard size sheet of paper that's 8.5 by 11 also is a constant, right? So the width and the height of that piece of paper are values that, I can't walk up to the printer here in the hallway and get out a different size piece of paper, because there isn't a different size piece of paper in there. Not that I couldn't cut it or buy different sizes, good luck with that. But that is considered a constant too. So in the US, a standard size business document is 8.5 by 11. So we could make those constants in our program also. So that's what I'm going to do. So I'm going to create width of paper. And if you want to get really verbose, and this is kind of the modern trend, in inches. So not only am I declaring the width of the paper, but I'm saying that it's in inches so I know what the measurements are. So who's to say if I said width of paper and then I wrote 8.5 that somebody might not think that that's metric, right, or millimeters. Be verbose, describe what you're doing. And so the width is 8.5. right? Another constant. Okay, well, if the width is a constant, well, then the height is too. And you know what? Here's like where you can maybe do a little copy paste, just a recommendation, right? And then you can change the first word to length of paper in inches. And of course, the value has to change because that's going to now be 11. Now, there is a little bit of kind of interesting thing that happens here. And sometimes I kind of like blindly walk into it intentionally. You know, I guess that doesn't make it blind. But sometimes I kind of intentionally will lead you astray, and I think this is too early in the semester to do this. So in other words, sometimes when I code this stuff, I'll intentionally make mistakes just to show you what's wrong. But in this case, I'm not going to do that. And the thing that I'm not going to do is just type 11 here. I'm going to type 11.0. Does anybody know why I'm adding the 0.0 to it? This isn't really talked about yet in the book pretty heavily. Yes, sir.
It's
Right. So the other ones are already decimal values, right? And when I take a non-decimal value and start doing math with it, so a counting number multiplied by a decimal value gets treated differently than a counting number times a counting number, or a decimal value times a decimal value. And what we have is we sometimes get what we call casting errors. In other words, when I throw in a whole number and do some math with it, sometimes it will force the number to become a whole number or force the number to become a decimal, and sometimes inaccurately, right? So like you have to know the nuances of your language and how it handles those things in order to choose the right approach. The right approach here is to make all of them decimal numbers, because that way when I do the conversions, you know, because the millimeters per inch is 25.4. I might get a very different value if I don't have that 0.0 here. Yes, Miguel?
So if you had a full number, it will round it up.
Yeah, and it depends on which math operation you're doing. Yeah, it could round it up, absolutely. Or truncate it, giving you not the numbers you're looking for. And if you're looking for precision, that causes a problem, right? Okay, in some cases, the precision is irrelevant. You know, we're talking about a piece of paper. But what if your numbers are, you know, landing a man on the moon? You know, like 1 decimal point might put you on Mars instead of the moon. You know what I mean? So you got to be careful with the accuracy of your values. All right, so now we have our constants for the program. They're really just variables, folks, right? They're only constants in principle because of the all caps. All right. But now, in order to get the result, right, how would I convert the dimensions, right? So what thing are we actually, write a program that displays the dimensions of a letter size sheet of paper in millimeters. So I need to just say an 8.5 by 11 piece of paper has an area of, right? Because that's kind of what we're searching for. So if I was to do it like this, and so let me just give you a couple of examples here as I'm coding this. So you might want to wait before you start copying. But I'm going to kind of paste all this in just to make it go a little bit faster. So I'm looking for the answer for the area, and maybe answer isn't really even a good name for this, but if I was to multiply 8.5 by 11, and so this is kind of the thinking here, that's how I would get the area of the piece of paper in inches. Okay, so I could just put a calculator, and I can just, so 8.5 times 11 equals 93.5, right? I'm not going to bother to do it in my head, you know, but I could, or I could do it on paper. You may as well use the calculator to verify your responses. Now, this is kind of a secondary little tip here. You're writing a computer program that can do this calculation for you, but how do you know that the calculation is correct? The answer is by checking it somewhere outside the program, right? So pulling out a calculator or a spreadsheet, if that's your tool, or pencil and paper, whatever tool you use, you want to know what the answer is. So in this case, if I was just to multiply, and I'm just kind of giving you the example here, a width of paper in inches times the length of paper in inches. So I'm just demonstrating at this point. This is not the answer, by the way. I could just do a print statement here and type answer. right? And I'm gonna run this. And so it says 93.5. Okay, good, it's working. See what I mean? Right, so if that was the calculation I was doing, I verified it in my calculator, I made Python do it, and I know it's correct. So now I know that if I had like, different sized pieces of paper, I could throw them in here, change numbers, and it would work right. But now we want to do this conversion to millimeters to make this happen, right? So in order to do that, that's where the statement changes. So here I'm going to put the original statement back. So this is actually the correct calculation here, where I'm taking the width of the paper, multiplying it by millimeters, the length of the paper, multiplying it by millimeters, adding those together, and then getting the right result. Now, can I ask you this? Is that correct? Is that equation correct? So, Brian, you're intuitively saying no. What's wrong with this equation? I'm hearing divide. Nick? Aha. Yeah, we're supposed to find the dimensions, not the area. So this is like, okay, so I do this often in class. I sometimes lead you astray intentionally to see if you're kind of paying attention. Exactly correct. We are trying to find the dimensions, not the area. So is this how I would get to there? Well, I can tell you that this is correct if I just need the width in millimeters. So let's take this part. I'm just going to delete it. And I change my variable here to say maybe width in millimeters. And I want you to notice a couple different things that I'm doing here. All right. First of all, we're using this multiplier to get the answer, right? So if I put in 1 inch, the answer is going to be 25.4, right? The other thing that's happening is whatever the result of the calculation is, whatever is on the right side of the equal sign is going to get put into the box or the variable on the left side of the equal sign. And notice how I'm naming it. Width in millimeters is very verbose. Notice how it's different than the naming up here. Because this is not considered a constant. It all depends on what value I put in up here. All right, so that if that's the width, then I probably also can do the length in millimeters. Also notice that as I'm naming this, I'm using this technique called camel casing, right? When I have a logical new word inside the variable name, I start it with a capital letter. So there's a capital I and there's a capital M. That's also a convention. Are you required to do that? No. Is that what most programmers do? Yes. And it's like one of those things, and that's why we call it not a rule, but a convention. And people do it in all programming languages, by the way. Now, this calculation is going to be really, really similar, but the only real difference is its length of paper in inches times millimeter per inch. So now I have two calculations. And you know what? I want to verify these calculations first with my calculator. So here comes my calculator again. So the one calculation is going to be 25.4 times 8.5, which is 215.9, by the way. If you want to memorize that, go for it. And then the other one is 25.4 times 11, or 279.4. So those are our target numbers on the output. Now we need to put that into a print statement to show our user the result. All right, so this is where my suggestion is that your output to your user should be as verbose as possible, meaning don't just put the numbers on the screen. Don't just put like 279.4 times whatever. Okay, that's great. What does that mean? I don't know. That's what you're going to get from your user. And so what we'll do is we'll get a full statement in here like this. A standard sheet of 8.5 by 11 paper, and maybe we should add the word inch in here. Has these dimensions. And you know what? I'm going to give the dimensions on a separate line of text. So I'm going to start a new print statement here. And I'm going to say print. Let's see. So what should I put up on screen? What am I going to put up there? How about the width in millimeters? And since I'm outputting a variable, I don't need double quotes around it. But in order to show what's next, there's a symbol that I use to add a string to it. And what symbol do I use? Okay, there are double quotes involved. No, double quotes will work. But there's a piece of punctuation, or what would go here? A comma. Thank you, Miguel. Right? Now, in other programming languages, if you learn Java, for example, you use a plus sign. That's kind of like a weird thing about Python, by the way. So here we're going to put, okay, so width in millimeters, and then what are we going to say inside the double quotes? Millimeters. Or we can just say ml, right? By, and then we would display, once again, the length. And see how I'm letting the tool kind of find this for me? Length in millimeters, comma, another set of quotes, have a millimeter sign in there. And is there anything else we need to put in? So the output's going to say a standard size sheet of 11.5 or 8.5 by 11 inch paper has these dimensions. We'll say whatever our calculation is, millimeters by blank millimeters. That looks pretty good to me. Let's see if this works. I don't see any red marks in the margin, so my syntax must be okay. So I'm going to hit that run button and see where we're at. So here's our output over here, folks. And notice what it's doing. A standard sheet of 8.5 by 11 inch paper has 3 dimensions. These dimensions. 215, hold on a second. We came up with a nice clean number in the calculator. 215.9 by 279.4. This one's nice and clean, but this one is not. Does anybody remember the reason as to why that happens in Python? There's a whole thing in the book about it. All right, so here's what I'm going to challenge you to do. Read up on why. Python has this quirk that happens with some of its numbering, where it will display precision that is inappropriate for certain levels of mathematics. Part of it is caused by the fact that we are including the decimal point on the 11.0, right, and the 8.5. That's part of the reason why. Part of it is also how Python displays the results of calculations. Inefficient for simple numbers, super efficient for complicated numbers, which is why it's used for data science, by the way. So that might not be the kind of answer I'm looking for. Really, I just wanted 215.9, right? That's the answer I wanted. I can actually round those answers, and I want to show you how to do that because that's a pretty important skill. And the way that you do that is right down here, I will add a set of parentheses around my variable name. And then in front of those parentheses, I'm going to add this statement, round. Guess what that does? It rounds your value. Then how far do you want to round it? Then you add a comma inside those parentheses, and you indicate to how many decimal places you want this rounded. I only want to round it to 1. You know, I saw that the second variable, length in millimeters, came out fine. But you know what? It's probably smart to put the round command on that too, because I can't necessarily always predict how Python's going to handle things. So I'm going to do this. Just leave it up on screen there so you guys can all see it. And then what I'm going to do here is I'm going to save this and I'm going to run it, and now take a look at my output. which is right here, how nice and clean that is. All right, so this is the first exercise completion. Lot of concepts being thrown in here collectively. Just one tip, right? If not all of that stuck in your head right away, that's okay, right? Don't freak out. It will stick over time. And we're going to do a few more exercises here, and then you're going to see how it works. Did everybody get that to work okay? Brian, you're good? Anybody having any issues? Some people are still typing it in. So take a moment to type it in. I'm going to pause the video here for a second. And if you have any questions, this includes onliners too. Just, all right, we're going to move on to the next exercise. And let's see what the exercise number is on that one. I forget. Exercise 2.3 is the next exercise. So this one here, exercise 2.3, reads as follows. It says, write a program that reads a number and displays the square, the cube, and the fourth power. And it also says use the star operator only for the fourth power. Okay, so one of the things you will have learned in this chapter are some of the basic mathematical operators, right? And just as a kind of a quick review, there's the plus and minus keys. Those are pretty intuitive. The forward slash is the divide symbol, and the asterisk, which looks like a little star, is the multiply symbol. What is the star symbol? The power, right? Or raising something to an exponent, right? So, very good. Andre, have something to say? Nope.
No.
Okay. Yeah, a lot of people don't realize this. So when you're on Zoom and you say something and your mic is muted, your window still highlights. You know, so sometimes I see the windows highlighting like somebody's trying to say something and their mic is muted. So that's why I say that. All right, so let's jump into Spider and start coding some of this then. And this is kind of a fun little exercise because we are working a little bit with math, but we're also working with mathematical output. We're going to be working with putting stuff into variables and then displaying those variables. So it's kind of a combination of all those skills. And once again, I'm going to try to put comments in the program just to show you that it's kind of a good habit and why we even do it in the first place. I'm going to go ahead and create a new file. So I'm just going to hit this new file icon here and name my file. So this is going to be save as immediately. Going into the same folder, which is good, and we're going to call it exercise 2_3 and save. And zooming in so you can see the work. With this one, once again, I'm going to copy the description in and paste it here at the top, just for handy reference. That is not something you guys are obliged to do, but just a helpful tip once again. The reason I started doing this kind of stuff is because I got sick of like bouncing between documents and pulling in information. It's like, what was that information? Heck, I'm just going to paste it in here so I don't have to go back and forth. You can delete it later if you want. It's not necessary for it to be there. All right. The first thing that I saw in the description, it says, write a program that reads a number. Okay, so that first phrase, reads a number. So what that means is your user is going to type the number. So now we're learning one other brand new skill, and this is pretty a cool one, is we are going to ask the user for some input. And we have a special statement in Python for doing that, which is the input statement. It kind of goes like this. Input, right, and then parentheses, and then double quotes, please enter a number to see its powers, right? And then I want you to notice I put a little colon at the end and I'm adding a space. So this is going to pop up on the screen and then wait for the user to type something at the keyboard and press enter. And once they've done that, we will have received the value. Okay, so now there's kind of a secondary problem with this. if we're asking for information from the user, it has to go somewhere. You know where you put that? In a variable. So that's kind of the other important takeaway here. So I'm going to go to the beginning of the line, and I'm going to type a variable name, and I'm just going to call it, you know what, we're getting a number, so I'm going to call it number. Right? And that will work. Right? So I can have somebody type something at the keyboard, they press enter, that value, so I want you to notice this, so the result of this input statement, whatever's on the right side of the equal sign, will get stored in what's on the left side of the equal sign. Yeah, we have one other issue. All right. Now, this isn't intently written into the program, but there's some complications that could arise here. The way that I have it written right now, a user could have the prompt at the screen that says, please enter a number to see its powers, and they type yes. Not a number, a word. And you know what? The way I have this written, Python doesn't care what goes into the variable. So they could give me a bad piece of information, and then I try to do math on it, and my program will break. That's not something we want. So they have this other tool, right, that we can do this. So now in Python, you could do it like this. I could take the number in the aftermath, create a new variable, maybe call it number2 or something like that, and then run the integer command on the number that was received. So in this step, I would receive the number or whatever they typed, and then in this step, I would convert it to an integer or a counting number so that I could do my math cleanly and make sure that it works. And if it wasn't an integer, the program would throw an error message at that point and stop. Right? So, you know, I can't, basically saying, I can't do math on like text, you know. Now, another approach, and I'm gonna comment this out right now. So I'm leaving that approach on the screen, is that you can take this whole input statement here and put it inside a set of parentheses and do this conversion before it ever gets stored here. So watch the technique. Oops, type int, a set of parentheses wrapped around the whole thing. You do need 2 sets of them. So you'll get a prompt that automatically converts it to an integer and stores it in number in 1 step instead of 2 steps. Isn't that clever, right? Or if you find that confusing, and some people will, do it the way I did it before and just do the input, putting it into the number, and then the other statement on the second line. And I'm just going to put a little note here, or you can convert to an integer after. Okay. That's just my little note. What are we doing in this first section of code? We're getting a number from our user. So often what like a programmer would do is describe what's about to happen. So get a number from the user. All right. After we have the number, now we can do the math. And in fact, that might be a good comment for what comes next. Do the math. Now, these are processing steps, folks. So the user will not see this stuff in the background. We were told to calculate the square, the cube, and the fourth. So I'm going to create variables called the same thing. Hey, why not, right? So I'll create one variable called square. How do I get the square of a number? I can multiply the number times the number. Yes, Nick? No, not at all. Would the square be considered a constant? None of the values here would be considered constant, because everything is going to be dependent on what the user types. Right. So that's actually a really good question, though, Nick. So next question was, would any of these be considered constants? Right. So in the 8.5 by 11 piece of paper example, where we had a standard conversion amount, and we had a piece of paper that has standard dimensions, absolutely those are constants. In this case, because the user's entering the value, that's going to be a variable anyhow. Therefore, the math that results from it is also going to be a variable. So all of these are going to be variables in this case. So we're just going to multiply number times the number to get the square. Okay, so how do I do a cube then? Which is the number to the third power. Well, I could do number times number times number. Right? Multiply it against itself through time. So if I say, I don't know, x to the third power, that's one of the ways you figure it out. That's really what's happening in the background. Now, the assignment instructions also say that you should use the power symbol. See, use the star star operator only for the fourth power. So if somebody are wondering, why don't you just use the power operator right from the get-go? Because that's not what the instruction said. So for the last one, we will just simply take the number, and then when you do star star instead of 1 star, that's the equivalent of raising it to the power that follows. So we're doing 3 separate calculations off the same number, storing the result of each one of those calculations into a variable. Now that we have done the math, now we do the output. All right, and so in this section, display the results to the user in a friendly way. Now that sounds a little cheesy, but I'll tell you what. Think about like when you sit down at the computer and you're using the computer. Have you ever used a program and something happens on the screen and you're like, really? You know, like you're almost shocked at like what comes back at you. Like it doesn't make, like, couldn't you tell me what this is? Or, so always think about what, from the user perspective, what the user might want to see. And generally speaking, they want to see the information clearly presented, well labeled, and understandable. Okay, so I'm going to do a kind of a series of things here to kind of make it that. So the first thing I'm going to do is I'm going to print a blank line, right? Because if you remember, when you do output like this, it'll do this gobbledygook first, and then it gives you your output, and there's not even a space in between it. That's kind of hard to read. So I'm going to decide to print a blank line first, and then put a message on the screen. So now I'm going to have a series of print statements, and so I'm just going to copy and paste those. And so first I'll say, thank you. I'm being polite, right? Thank you for entering a number. Here are your results. Right? Then you know what? We'll skip another line, make another blank line. Another blank print statement. And now we'll give the first result. So we'll say print. And what are we looking at first? The square. The square of your number is, and then we'll output the square. Now notice I'm still inside the double quotes. It's not where I want to be. I actually want to be like this. And if you really want to get particular about it, you could, instead of saying the square of your number, you could just say the square of, list the number, and then put that on the screen. That's up to you, right? I'm doing it this way. You do it your way. In addition, I'll then want to put up the cube. So there's my cube. The cube of your number is the variable cube. Your number to the fourth power is fourth power, or I called it fourth here. Oops, and you notice here, so I see the red mark. I forgot a P with the print. Oops. That's kind of a major one. Then I'm going to do a blank line. Oops. Let's do a blank line here. And then, hey, let's be extra nice to our users and say, thank you. Come again. that might be overly polite, but I'm trying to drive home a point here that you can try to make your output look nice or be more informative. So I don't want you just like writing a print statement that outputs square, cube, and fourth with no information, because that's irrelevant. It doesn't tell the person anything who's using the program. Now in the console here, I'm gonna click over here to the console and enlarge just a click here. And then I'm gonna go ahead and run this program, hitting that run button. And so here comes the prompt. Please enter a number to see its powers. So I'm clicking, and you guys notice as I had to click on the console area, I had to click down in this part of the window to activate the console, and then my cursor started flashing. Now I can type a number. I'm gonna put in the number. You know what? I'm gonna put in a number that's really easy to see if the math is right, like the number 2. So I'm not gonna put in like 1,345 because I don't know that math off the top of my head. Number 2 I can figure out, right? So now I press enter. And it says, thank you for entering a number. Here are your results. The square of your number is 4. That's correct. The cube of your number is 8. 2 times 2 times 2 is 8. That is correct. And your number to the 4th power is 16. That's also correct. And then I have a little thank you message. You know, that might be a little excessive. You know, so I maybe went a little overboard with the user-friendly part of it. But I'm trying to make a point, you know, you can make your output look a little nicer and be informative. And at the very least, you should provide the user with enough information so that what they're looking at on the screen makes sense to them. And I see you guys are all busily coding, so I'm leaving this stuff all up on the screen here. And then I am going to pause the recording. And then once again, if you are running into issues, you know, throw something in the chat, unmute. So now we're going to move on to exercise 2.4, and this is kind of a multi-parter. So there's a little bit of work to do here. And it says, write a program that prompts the user for 2 integers. So we're going to get 2 values, both counting numbers, and then does the sum, the difference, product, average, distance, maximum, and minimum. And then it says hint, Python defines max and min functions that accept a sequence of values, each separated with a comma, right? So they're hint, 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 right? Now, the hint also does go back to the chapter, so there's parts in the chapter that talk about how to do that. So if you were like sitting on your own doing this and didn't know what the answer was, or maybe you thought, hey, I could go right to the exercises and not read the book, because some people do that, the stuff is in the chapter. They don't just throw this stuff at you out of thin air. You know, all the reference materials are in the book, but then again, I will do this for you as well. So I'm going to copy this description. I'm going to bring it over to Spider, so when I start my new file here, I can type it in. First thing we do is save as. This is going to be exercise 2_4. And we'll do a little bit of zoom here. And I'm pasting in the instructions, even though they're kind of long. But whatever, now it's on screen here. I don't have to flip back and forth. All right. Here it says, write a program that prompts the user for 2 integers. You know what? We just did that in the last program, right? Is there any reason why we couldn't just copy that? None at all. You know, let's be smart, copy code that works. And I'm just going to grab actually these first couple lines here from the last program and paste it in here, along with the comment. And actually it says get 2, so I'm, you know, integers, let's be specific, from the user. And since we're going to have 2 numbers, I'm going to change the name of my variable here, by the way. So I'm going to call it num1. And actually, this isn't going to be right. Please enter an integer. That's probably enough, right? So the rest of this I don't really need. And then I'm going to paste this. Now I'm going to change the second variable name, and I'm going to call it num2. And for the second line, I'm going to say, so we know it's a different line. Please enter please enter another integer, right? Sounds good? And I think by the time we get to the second one, we don't need the description. It'll be on screen still anyhow, right? So that's our input. Right, that's step one. Now we need to get the math going in the background. There's nothing else really in between here. So the approach of, do the math is pretty appropriate here. All right, so let's talk about this. We have to do a sum, difference, product, average, distance, etc. So let's start with the sum. And so can I use the word So I thought maybe I could name my variable sum. Did you guys notice it just color-coded? When a word color codes in Python, what that means is it's what we call a reserve word. It's used by the language for some special purpose, just like input and integer are, right? So that I can't call it sum. Maybe I could call it my sum, or maybe sum of numbers. Maybe that's better. Sum of numbers. So how do I get the sum? I don't know, num1 plus num2, right? All right. Maybe then we can also do the difference. And I'm intentionally calling it something short here. And in this case, I'll get the number, the first number, minus the second number. That's the difference. The product, that's just multiplying. So I can go num1 times num2. Next, they want the average, so I'll create a variable called average to store that value. Now, the way an average works is you take all the numbers that you have, add them together, and then divide by the numbers that you have. Now, we already added them together, right? So I can just take sum of numbers and divide by what? 2. Another one that we need to figure out is the distance. And the distance really refers kind of to the Cartesian coordinate system, a number line, if you will. And the distance is the amount of space between two numbers on a coordinate system, regardless of if they're negative or positive. So if I had like -2 and +2, their distance is what? 4, right? You'd have to count 4 over to go from -2 to -1 to 0 to +1 to 2. That's 4. Right, so that's the distance. And they have a function in Python called the absolute value, which you abbreviate ABS, and then you just put in, well, how would I express this? Well, we've already actually done the calculation, which is the difference. The difference between the two numbers may end up negative, but the absolute value of it is the distance between the numbers. That's kind of the logic here, right? And this is not, you're not being quizzed on what absolute value and distance are here. This is just a formula, so just copy it and go with it, All right. The other thing that they asked us for is the minimum and maximum. And I'm going to create a couple variables here for us. So I'm going to go my min. And the way that this works is you call the minimum function, parentheses, and then inside those parentheses, we will feed a list of numbers And it doesn't have to just be two numbers, but if we had like 100 numbers here, you could throw all of them in and it would find which one is the smallest. That's what this function does, right? With two numbers, pretty easy to do. What if you have 1,000 numbers though? Right? Do you want to look through that list? You program the computer to do it. That's the smart way to do it. You know, it seems silly when you only have two numbers to do it, something like this, but you know, hey, this is what we have right now. Yes, Brian? Yeah, you know, if you want to get all particular about it, Brian, you're totally right. You know, like if I'm doing like words like this, should I camel case and follow the convention? Probably. You will notice programmers sometimes get lazy. I'm guilty of that myself. And it's okay to correct me. So thank you, Brian. So this one is the same as the one above. We're just using max as the keyword. All right, so those are all of our mathematical equations. The other thing I'm going to kind of put up here, this is kind of interesting, because I don't know if you guys remember this discussion from when we talked about like problem solving, how there's this theme in computer science, and it's called the systems approach, where programs often operate like this. You get input, you do some processing, and then you output the results. And this is really a classic example of it. So it just popped into my head. So I'm like, you know what? I'm going to add that to my comments. And so now we're going to display the results. And in this case, we're doing output. So here's your input, processing, output. The user, these two steps here, right? So if you're thinking of like flowchart or pseudocoding, these are user interactions. They would go in parallelograms. These would all be processing steps. They would go in rectangles, all of these. And then the output would go into parallelograms, which all is interfacing with the user again. Right. So now we're going to do, once again, a series of output statements. I'm going to kind of follow the same approach I did last time. I'm going to start with a blank line. Why? Just looks better, you know? And in fact, I can even say, prints a blank line to make it look better. Not like a programmer really needs that in there, but hey, you want to be verbose? Doesn't hurt to put it in there. Doesn't keep the program from running or anything. All right, so with the rest of this, now we're just going to output the results. And so you guys can probably do this. And all I'm going to do is have a print statement that says what I'm outputting and the result. So for example, print for the first one, what am I printing first? The sum. S-U-M. I'm going to put a colon after it and a space. Then I'm going to move outside the double quotes, put in a comma, and then I'm going to have sum of numbers. It found it for me. Next line, we'll do the difference. And you guys should be able to see the pattern at this point, I would hope. And then you just start typing in all the different monikers and variables that go with. So diff. And then because I'm exceptionally lazy and already have done the work in the past, I'm going to copy and paste the rest. Right? You guys, hey, that's not fair. Like, you're absolutely right. It totally isn't. I do have to correct a couple variable names here. So there's all my outputs, folks, and the completed code. I know you guys are going to take a little bit of time to do this, but as you guys are kind of typing the stuff out, I'm going to go ahead and save this. So I got my control S in there, and now I'm doing a run. And so now it is prompting me here. So I'm just going to bring it up in the console. Enter an integer. I'm going to enter the number 5 and the number 10. Right, those are my two numbers. Press enter, and there's all the outputs. Now, the smart thing to do, of course, is to go ahead and check all those answers. So is 5 plus 10, 15? Yes. Is the difference -5? Well, if I subtract 10 from 5, yes, it's -5. Is the product 50? Yes. Is the average 7.5? Well, 7.5 is right in between 10 and 5. Yes, it is. Is the distance 5? Yes. What's the maximum number and the minimum number? Minimum is 5, maximum is 10. Spot on. But please take this to heart, right? And this comes from many, many years of programming. Don't assume the computer is doing the math correctly. It is only doing exactly what you told it to do, and hopefully you told it to do what is correct, right? Sometimes it seems like it's correct and it's not. So the process of double checking the math is really an important one. But once that algorithm or the math part is set, you shouldn't have to ever mess with it again. And then once it's all set up correctly, you should know with extreme confidence that you can feed in whatever value and get the right response as a result. All right, so that was exercise 2.4. All right, I'm going to pause here once again and give you guys a minute to kind of catch it. All right, we're going to move on to the next exercise. So I'm going to take a look here at the course shell. The next exercise is exercise 2.8. So let's pull that up in the instructions here. So exercise 2.8 says, write a program that asks the user for the length of the side of a rectangle, then print the area and perimeter of the rectangle and the length of the diagonal. And for anybody who has had any math, you guys should be knowing really quickly, we're talking Pythagoras here, right? When we're getting like the diagonal of a rectangle. Don't worry, I will give you the calculations. But Pythagoras, the Pythagorean theory is one of those real basic ones. A squared plus b squared equals c squared, right? And it's a really important one, I mean, mathematically, that's one of those ones you should just know. But if you forget, you can always look it up, not a big deal. All right, so I'm copying the instructions in, back over to Spider, new program, hitting the new button up here. Save as, and this is exercise 2_8. All right, and then I'm going to take those instructions that we got and just paste them here at the top for handy retrieval and reading. All right, now we need to think a little bit about what should come first. Now, if I heard it correctly, I think they said that we should prompt the user for it, right? Yes, that's exactly correct. So the first thing that we're going to want to do here is prompt them. Now, here's kind of the one issue that we're going to run into. So, and this is one that comes with experience, frankly. When we start to type in numbers, we can't necessarily assume that the user is going to type in a whole number always, because you know what? Maybe this rectangle is in the form of a decimal number, right? And so maybe the user will type 2.75 for the length. So why don't we set it up so they can type in a decimal number if they want. So we're going to kind of do the same thing. We need the length and the width of the rectangle. So I'm going to set up one variable for length. And then for this one, I'll type my input statement. So my input statement will say, enter the length of the rectangle. All right. I'm not putting it into an int conversion. This time I want to allow for floating point. So I'm going to actually force it to float. So I'm going to put that whole statement inside of this statement that says float the inputs. In other words, whatever the user, if the user types in a whole number, like the number 2, you will convert that to 2.0. If they type in a decimal number, we're all set. Right, so that works really well. We also have to do the same thing for width. So that's a pretty easy copy, paste, and adjust. So we'll just change this to width, and let's Just change that word there. All right, if we want to be really polite and everything, maybe we should put in some comments here. Get input from our user. All right, so once again, we're falling into this format of input, processing, and output very classically. And the next part, once again, is kind of like do the calculations or do the math. I'll say calculations in this circumstance. Do the calculations. The thing that they're asking us for is they want the area and the perimeter of the rectangle. All right, so area, how do we calculate the area of a rectangle? Sounds like the fertilizer problem, right? What's the calculation for that? Length times width, right? So we are creating a variable called area. It will be equal to the length and times the width of what the user entered. Next, we are going to calculate the perimeter. Now, the perimeter of a rectangle is the measurement all the way around all four sides. So that would be, well, if you think of how a rectangle is, if you use this box up here on the screen as an example, well, it's the length, well, that happens twice though, and the width, and that happens twice, right? And so we could probably abbreviate that and say length times 2. And some people would probably want to put it in parentheses. In fact, that's not a bad habit to get into. So that's the one calculation, plus width times 2. Now the reason, just to reiterate from the readings, the reason that we put parentheses around mathematical calculations is to enforce that that operation happens first. So there's this thing in mathematics called the order of operations, and it was part of the topic of the chapter, which is the order in which you calculate things in an equation if you're just looking at it from scratch. So for example, does anybody know what the acronym is that helps you to help remember how to do that? PEMDAS, or please excuse my dear Aunt Sally, or there's different number of ways to do it. But what it stands for is parentheses, exponents, multiply, divide, add, subtract in that order. Now, if I was to eliminate these parentheses, would this calculate correctly? It absolutely would. And this is one of those things that programmers often learn to see pretty quick, because the multiplication will happen first anyways. Then, so it'll multiply, and then add them together. That's correct. So you really don't even need the parentheses, by the way. If you put them in, fine. It just proves that you're aware that it needs to happen first. Is it functionally necessary? No. The multiplication will happen first anyhow. All right. The next part, the diagonal, well, that one does require a little bit of Pythagoras. And more importantly, if you guys remember your geometry or whatever you want to call it, because I know a lot of people, that's like their least favorite topic, right? So we're taking a rectangle, all right, and this is very poor art with the tool I have available, whatever. We have a rectangle. We want the measurement of this line. And so if you remember Pythagoras, right? So this might be your A side. This is your B side. And then this is your C side of the triangle. And the formula for calculating C is A squared plus B squared equals C squared. Okay, that's all well and good. I can square the numbers just fine. But ultimately, I don't want C to be squared. I want the square root of C. And that requires a special mathematical tool that isn't built into Python without doing an import from its math library. So this is our first import that we're writing, folks. And so what we're going to do here is at the top of our program, once I get out of annotation mode, is I'm going to add, I'm still there, okay, sorry about that, darn Zoom, is I'm going to add a line of code up here, and I'm going to type from math, which is our math library. We are going to import the square root command. If we don't perform this step, when I type the square root command, it won't work. Square root's not built into the base part of the Python language. Like a lot of other higher end mathematical functions, the math libraries in Python are actually, and a lot of people aren't aware of this, are actually built upon the libraries from C and C++, as are most programming languages, because those people developed all this stuff like 30, 40 years ago, and once the code's developed, why would you ever rewrite it? You know, it's kind of the thinking. But we have to import the library in order for the function to work, so that's what we're doing here. Now, we are going to need to write this formula, and rather than get into like the specifics of why this works or whatever, we are going to take the length squared plus the width squared, which will give us c squared, but remember, we want the ultimate answer being the square root of c. So we're just taking those two things added together and taking the square root. Now, this is also part of why we also set up here in the input statement to do a float, because if we don't float, then we lose the precision on the diagonal calculation. So that's another reason. So if somebody types in the length as 2, it will convert to 2.0, and then in the calculation for the square root, it will give us more precision. But these are all of our calculations. One thing left to do is do the output. So display the results. You know, and if we want to do this part again, input, processing, output. Again, a very classic approach to writing software. Ultimately, when it comes to doing the output, you're going to write statements that look like this. And so I'm just going to paste in the first couple. So I'm going to say the area is area, right? So I'm going to output whatever we calculated. The perimeter is whatever we calculated. All right, but when it comes to the last one, and I'm going to show you, kind of demonstrate, and then show you what the fix is. So here we're going to say the diagonal length is, and then normally we would just like leave a space, put in a comma, and type diagonal. And I'm going to run this. I'm going to show you what the output looks like, and then I'm going to show you some basic formatting commands that are helpful. All right, so we're just going to do it straight up like this first. So I'm saving my work, and I'm hitting the run button. And so let's take a look at what happens on the screen. First it says, enter the length of the rectangle. I'm going to put in really simple numbers. So now, does anybody know the rule of 3, 4, 5? All right, so this is really helpful, and this is how a lot of like people who are like contractors can build things that are perfectly square using really simple little tools. So, and this is, I think, actually very helpful to know, right? So if I have one side here, if I have a measurement of, let's say, 3 feet, so let's say this is 3 feet, and then I have another measurement that's a little longer, 4 feet, I know the third side is 5 feet. Don't believe me? Do the math. 3 squared is 9, 4 squared is 16. Add those together to 25. The square root of 25 is 5. So the rule of 3, 4, 5. So a lot of contractors know this. They just measure 3 feet in one direction, 4 feet in the other. Although all they have to do is connect the other side, and it's a perfect triangle. And they have a square corner. Now, so this corner down here is perfectly square 90 degrees, even though my drawing is not, right? All right, so that rule is really helpful. So the numbers I'm going to enter in here, which are really easy to work with, by the way, I'm going to enter in the length is 3, the width is 4, and notice the diagonal length is 5. So it came up with the right answer. Okay, and it says 5.0. Okay, so what if it's not quite so clean? Okay, so let's put in numbers that don't come back so clean. Let's run it one more time, and this time I'm going to put in, I don't know, 56 and 79. You know, not nearly as clean. And then look at the output on the diagonal. Well, that's a 96.83, blah, 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 whatever, right? And the reality is, we don't know if this is inches or feet or yards or meters or anything like that. We have no clue. It doesn't really matter, actually, as long as the measurements are consistent. But I'm going to argue that even if it's like feet and inches and millimeters, kind of like everything past the second decimal place is kind of like, yeah, whatever, you know, can't even measure it kind of thing. And so displaying these extra numbers is not really useful. So here's a little trick that we do in Python. Interestingly, we use the exact same approach in Java, you guys. So people learning Java, it's the same approach. And here's the secret answer to that. Java uses the C++ libraries, and Python uses the C++ libraries to do the formatting command. So we use this common set of commands to do it. And so one little trick that we've learned to do is this. So instead of using a comma here, we will instead switch that to a percent sign. That tells us that we're doing some formatting. And the formatting command is actually included in plain text right before the closing double quote. And in this case, we're going to say whatever number we put in, we're going to display it to 2 decimal places, and there's the F for the formatting command. So the switch here is this. So these characters here were switched. The comma becomes a percentage, and then we indicate the percent sign here indicates whatever the number is to the second decimal place. That's what we're formatting it to. This is a really common format, for example, if you're doing dollar amounts, because when you're doing dollar amounts calculations, you know, anything that's smaller than a penny is irrelevant. So we truncate it, we format it. All right, so let's run the same thing again with the formatting command in place, and we'll feed in the same numbers, 56, and what do they do, 79, and now look at the output, a little more useful. All right, I am going to stop the recording here, just so you guys are aware, and I'm open for any questions that you might have or any additional help. So the recording ends here.